Hello, this is Mr. Collier, and today we're going to look at the chi-squared test for independent and how to calculate that on our calculator. First, we're going to look at degrees of freedom, and what that basically means is, for example, if I've got this contingency table here, and I know the sum of in this case, sum of B1 is going to be 26, and these are the column sums and the row sums here. So what happens is if I set one of these values to, let's say, 10, then what happens is you can figure out the other three values. Okay, so basically all the other three values depend on this one right here. So you're only free to choose one value in this table, and then all the other ones are determined. Alright, so you can calculate or figure out where all the other examples are. So there's only really one value that you can pick, and then the other three depend on that one. So in this case, the degrees of freedom is 1. If I look at this case right here, if I know that this is, say, 4 and 2 and then 3 and 1, something like that, then you can figure out the rest of the values. Okay, so this one would be 6, and this one would be 4, and this one would be 6, and this one would be 6, and this one here would be 1. So everything depends on these 4 right here. So in this case, the degrees of freedom is 4. So if you look at the table, we got degrees of freedom is 4, and basically you can get that from this 2 by 2 bit right here. Okay, so the degrees of freedom is always the number of rows minus 1 times the number of columns minus 1. In this case, we have a 2 by 2 contingency table, or sorry, 3 by 3 contingency table. So the degrees of freedom is going to be 3 minus 1 is 2, times 3 minus 1 is 2 equals 4, which is what we had from just analyzing the contingency table. Okay, also important are critical values. This is how you tell if you reject the null hypothesis or accept the null hypothesis. Okay, so for degrees of freedom 1, for example, if you have degrees of freedom 1, like our first example before, and you want a significance level of 5%, which is usually the norm, then if the chi-squared value that you calculate, if that's going to be greater than 3.84, then you reject the null hypothesis. If it's less than 3.84, then you accept it. Okay, so we're going to take a look at that in a second. We're also going to be calculating a p-value on the calculator, which can help us determine if we accept the null hypothesis or reject the null hypothesis. Okay, so we're going to go through this basic outline where we're going to follow these steps. We're going to state the null hypothesis and the alternative hypothesis, find the degrees of freedom, figure out what the significance level is, and use the critical value to either reject or accept the null hypothesis, and take a look at the p-value as well. Okay, so we're going to follow these basic steps for the next couple of examples. Alright, so in this example, for a math studies project, a student gave his classmates a questionnaire to figure out. Okay, these are the results, and it's in a 2 by 3 contingency table of observed values. Okay, so firstly, we're going to calculate values of P, Q, and R here, the expected values of P, Q, and R. So for P, we have P in this position right here. So P should be equal to the column sum times the row sum divided by the total, which in this case is 100. Okay, so these numbers should add up to 100, and these numbers should add up to 100, which they do. Okay, so I'm going to use a calculator to work that out. 42 times 60 gives me 2520, and then divide by 100 She gave me 25.2, of course. So that's 25.2. Alright, and then we do the same procedure for Q and R. So Q is going to be 42 times 40 divided by 100. And R is going to be 31 times 40 divided by 100. Okay, so I'm going to work those out real quick. 42 times 40 and divide by 100 is going to be 16.8. So Q equals 16.8. And R is going to be, okay, 31 times 40. I'm going to divide by 100. 12.4. So R equals 12.4. So we have 12.4 here, 16.8, and 25.2. Okay, so that's part A. Part B is find state a suitable null hypothesis. Alright, so null hypothesis, now let's take a look at subject and gender, okay? Choice of subject, okay, so null hypothesis is always that they're independent. So your null hypothesis is choice of subject is independent of gender. Okay, if they ask you for an alternative hypothesis, then that would be choice of subject is not independent of gender. Okay. Show that the number of degrees of freedom is 2. Well, we have a 3 by 2 or 2 by 3 contingency table. That's a 2 by 3 contingency table. So the degrees of freedom equals 2 minus 1 times 3 minus 1, which equals 1 times 2, which equals 2. So the degrees of freedom is 2. Okay, write down the critical value of the chi-squared at 5% significance level. So we need to look at the table for that, or oftentimes they'll just give you that in the question. So 5% significant level at 2 degrees of freedom. So I'm going to look back at my table. 2 degrees of freedom, 5% significance level is 5.99. Okay, so I write that as kind of like this chi-squared at 0.05 is 5.99. Alright, so when we go and calculate the chi-squared, oh actually they already have it right here for us. I'm going to actually show how to do that on the calculator though. Okay, so if we want to, I'm going to go back and type in that information and calculate the chi-squared value. Alright, so I can type in that in matrix, so second function matrix. I go over to edit and put the information in matrix A. It's a 2 by 3 contingency table, so 2 by 3, and then I start typing in these pieces of information. So 22, enter, 20, and then enter, and I'll type all those in there. Okay, I got my matrix done. Now we're going to calculate chi-squared, so we go to stat, go over to tests, and it's actually way down there at C, so you could type in alpha and then C, or scroll down. Actually, alpha C would have been a lot easier. Okay, there's the chi-squared test. So press enter, and yeah, so you should always put your observed data in A, and that'll put the expected values in B. So I'm going to calculate. Okay, so there's chi-squared. df is 2, so degrees of freedom is 2. And the p-value is right there. We're going to use that p-value in a bit as well. Alright, so I'm going to maybe copy the whole thing here. Alright, so I'm going to put that over here. Yep, so Yes, the chi-squared value is 1.78, like they say right here. So do you accept or reject the null hypothesis? Well, let's take a look. We have our chi-squared value equals 1.78, which is less than 5.99. Okay, this means that we accept the null hypothesis as being true. So in other words, choice of subject is independent of gender. Okay? Alright, so we got that conclusion because our calculated chi-squared is less than our critical value. Alright, that's always going to be the case if it's less than the critical value. Yeah, so if your calculated chi-square value is greater than the critical value, then you reject it. If it's less than the critical value, then you do not reject the null hypothesis. Okay, so our chi-squared test for independence in this case tells us that choice of subject is independent of gender. We can also look at the same determination with the p-value. Okay, so the p-value is 0.411, which is 41.1%, which is greater than 5%, and that is our significance level. Okay, that's our significance level. Significance, okay. So if your p-value is greater than the significance level, that means that you accept the null hypothesis. Okay, the second example here, the eye color and gender of 500 students are noted and the results are indicated below. Okay, so the null hypothesis in this case would be that gender and eye color are independent. That's the null hypothesis, and the alternative hypothesis is that gender and eye color are not independent. That's always the way it's stated, not that they're dependent, but they're not independent. Okay, show that the degrees of freedom is 2. The degrees of freedom is always row number minus 1 times, column number minus 1 times row number minus 1. So that gives us 1 times 2, which equals 2. Okay, this is a 2 by 3 contingency table, so the degrees of freedom are going to be 2. Right, so that's our degrees of freedom. We're going to write down the critical value for the degrees of freedom. Okay, so we're going to do that now. We're going to write down the critical value for degrees of freedom. So the degrees of freedom is 2, and we want a 5% significance level. So I think that's going to be the same as before. It's going to be 5.99. Okay, so 5.99, like in the example before, is going to be the critical value we're going to be looking at. 5.99. Oh wait, now hang on a second. Let me see that again. Yeah, 5.99 is what we're looking at. Okay, so that's the critical value for 2 degrees of freedom here, and 5% significance level. So there should be another question here actually that says calculate the test statistic for this data. So we're talking about the chi-squared statistic. Alright, so we're going to calculate that now on our graphing calculator. So I go to second function, matrix, make sure I go to edit. Should be 2 by 3 if you don't already have 2 by 3. And I'm going to type in this data. Yes, there it is. Alright, so I'm going to go down here. Yeah, type in the data. Okay, so I've got my matrix done. Just checking to see if all the numbers match. Good. And now I can go calculate the chi-squared statistic by going to stat. Go over to tests. I can type alpha c because it's all the way down there. Enter, enter, enter. And there's all the information I need. So let me copy that. And I need all three of those, I think. Okay. So we already got the degrees of freedom is 2. We got that before. Chi-squared value is, in this case, is equal to 4.48 to 3 significant figures. Alright, and we saw before that the critical value at 5% significance level is 5.99. Okay, so the chi squared equals 4.48, which is less than our critical value of 5.99, which means if it's less than that, then it's always going to be accept the null hypothesis. Okay. So part E, does the evidence suggest that eye color is related to gender at school? Yeah, so no. You can say the chi-squared test shows us they are independent. Alright, and also you could say too because of the p-value. So let's look at the p-value. The p-value equals 0.106, which is 10.6%. This is greater than the 5% significance level. Okay, it's greater than that, so that's also evidence that that we accept the null hypothesis. Alright, so you can use the critical value to show that we accept the null hypothesis, and we can use the p-value to show that we accept the null hypothesis.